Hello, hello. Good evening, everyone. Good evening, Tamenglong, Itanagar. How are you all? And please mark your attendance, all of you. Yeah, thank you, Tamenglong. And what about Itanagar Center? What is your attendance at Itanagar Center? And tell me, how are you? Going good? So, okay. Thank you, Itanagar. Very good. And all present. Great. So, in the last class, we have started circles, and it is basically the last chapter, I would say, right? That we are going to discuss, because after this, one more chapter is there, which is construction. So that is in all of the board, I guess. There is one or two more chapters, but they are not in each and every board. So I would say the last chapter is going to be construction, but probably I'll not be covering this. I hope you guys are getting the reason also, because in construction now, things will be good if I'm presently, physically present in the classroom, and then I'm doing all that arc part, how to make these arcs, this measurement, this particular scale, right? So I think that circle will be a last chapter, technically. Okay? Yes, I'm fine. I'm totally fine, and thank you for asking, Itanagar. Good evening, Ukrul. Good evening. Please mark your attendance, Ukrul. So yes, maybe in this class, not in this class, but yeah, we'll take one more class, and by that class we will finish the entire syllabus, right? And then we will start revising. So that is up to you guys, which chapter you want me to revise it first. Okay? So you can respond to that here as well. I mean here only, if you want to, if you want to revise something in particular, like this chapter, so this particular topic, or series of chapter maybe, right? So yes, you can tell me over the WhatsApp or in the classroom itself, right? Accordingly, I'll make the plan, revision plan. Okay? So this is how it's going to work. Yeah, we'll do that, Itanagar. We will do one class on Heron's formula. Not even one class. So basically, in one class, what I'm going to do now, we'll try to wrap up 2 or 3 chapters, I would say, right? As in, Heron's formula is very small topic. There is a formula. You just have to understand the formula, how to apply, and what are different aspect of it. So it will take around, I would say, maximum of 1 hour, right? So yes, apart from this, we can also do one more chapter. So likewise, is that clear? So you have to tell me which chapters you want me to revise. Now this is up to me, how many questions I will take. Don't worry, I'll make sure that you guys are getting, the purpose will be fulfilled. That is my promise. Okay. So I understand. So Itanagar is requesting for Heron's formula. Is there any other chapter? Itanagar, everyone, you all can respond. I'll write it here. Don't worry, I'll write it. And we'll make my revision plan accordingly. That we will be following probably by the next week. Not by the next week. After that. Alright? After that we will follow that. Number system, okay. Tamenglong is saying number system. Number system, okay. And Ukrul, what about Ukrul? Don't you have any doubt? Any topic, any chapter? Yeah, sure. Okay then. I don't think there is any doubt in circle chapter, what we have discussed so far, right? That was just the terms we were defining. Okay, what is radius, center, congruency of 2 arcs, what is diameter, what is a chord, all of this I think we have covered, and there is no doubt. Okay, so let's move ahead in this chapter, and today we will be starting. Okay. I'll make. So basically, I have to cover entire mathematics again, I guess. I'll do that also, not an issue because we have time, right? So let's start with the circle. All right. First of all, we will talk about some theorem, some important theorem, and congruency of, as guys in the earlier classes or in the previous chapters, we have studied about the congruency of two lines, two line segment, and circle, not circle, triangle, quadrilateral. So all of that we have covered, right? How two triangles are congruent, what are those parameters, what are the methods to find out those. Is that clear? So here as well, we will talk about congruency of two circles or two arcs, right? Part of a circle. So let's start with this. Congruency of circles. Congruency of circle. Two circles are said to be congruent if and only if IFF stands for if and only if if and only if either of the two can be superimposed to the other, right? In order to cover it completely. What does that mean? That means center has to be, of course, same at the same point, right? So what I'm saying is, thus circle whose center is R, whose center is at O and radius is R, and we have another circle which is O and R dash. So O is the center again and R dash is going to be the radius. They will be congruent if and only if R equals to R. So of course center has to be same, right? Now as we are saying that one has to cover the second completely, so that means R has to be same. That is the only possible way in which both these circles will look like identical or they will get superimposed, right, to one another. So this is nothing but the congruency of circle. Very simple. Next is second is congruency of arcs. So what is congruency of arcs? Two arcs of a circle are congruent if and only if either of the two can be superposed can be superposed sorry can be superposed on the other in order to cover it completely. Right, again the same definition almost, but yeah, as in this case r and r dash were supposed to be same, so radius was supposed to be same. Here we will get a different condition, that is this one. Thus two arcs, let me take two arcs AB and arc CD are congruent if and only if, sorry, this pen is not that good, still I'm trying to write it properly. If and only if, what is the condition, guys? AB equals to measurement made by the arc CD. So what does that mean? That means AOB equals to COD. Now where's the figure? You see, this is the figure. If this is a circle, right, this is your center O, and I have taken, this is AB arc, if this is one arc, let me take, this is A, B, right, and this is some C, this is some D, this is your O, the center. So what we are saying is that these two has to be same, right? These two angles, this theta and theta has to be same. Then only we will be saying that arc AB is congruent to arc CD, if the center angle is same. Superposed is basically when there is something and it will completely cover it. If suppose this is some, any material, any letter, let me take some A, right? Superimposed or superposed means there is different A, which I'll write it and it will cover the entire red A. Superposed, right? They becomes identical. Okay? Is there any other doubt? Itanagar, superposed, that's a simple term, very simple term. Itanagar, is there any doubt? If any figure is given to us, and superposition means if you consider some other figure which you can, which you will be putting in such a manner, it will be covered completely. So that is nothing but superposed or superimposed. Okay? Okay then. So next is we will talk about some important theorems now, and just give me a moment. माइक बंद है ना? ठीक है, ठीक है. अरे पता नहीं वो चल अजीब सा रहा है, पता है? I hope there is no doubt, right? What is congruency? Next is, now we will talk about the important theorems from the chapter circle. So, important theorems. Okay. Now again, we are not going to prove these theorem because maybe you have already proved these theorem in the class or in your schools, right? So mainly we will be using all the applications, we will be doing question, and we will of course do some proof types question in which we will be indirectly using these theorem, or we will understand how to use the theorems. Okay. First one, theorem 1. It is equal chords of a circle sustained equal angles at the center. You can ask me, sir, this theorem, please prove it. So I'll prove it for you. But if you insist me to prove, because these are very easy, so I don't think there is, all time wasting if we are going to prove them, right? Second is, if the angle subtended by the chords of a circle at the center of the circle, if the angle subtended by the chords of a circle at the center of the circle are same, okay? If they are same, then the chords are equal. Chords means their length are equal. And of course, equal chord means, of course, we are talking about the length. Because chord is again a line segment, right? So for a line segment, we always talk about the length. Remember this. Then the chords are equal. Okay? Third. Theorem 3. It is the perpendicular from the center of a circle to any chord bisects the chord. You see, the perpendicular from the center of a circle to a chord bisects the chord. All right. So basically, here's the diagram. You see, this is your circle. This is the center, right? What is theorem 1 and 2 are saying now? You have to understand. Like this is one chord, right? And this is the second chord. Let me take AB. This is some CD. This is some CD, right? Now, we are saying that this angle, these two angles will be equal. These two angles will be equal. According to theorem 1, if equal chords, right, of a circle subtend equal angles at the center. If they are equal, if AB equals to CD, then we will get angle AOB equals to angle COD. And it is vice versa also true. Right? So if equal chord, angle will also be equal. If angles are equal, the chords will be equal. Clear? Next. Theorem 3, what does theorem 3 says? It says the perpendicular from the center of a circle to a chord bisects the chord. What is the diagram? Diagram, you can take this. This is the circle, right? This is the center of the circle. This is some chord given to us. Okay, let me take this as A, B. Now, the theorem is, if you draw perpendicular to it, it will bisect the chord. That means if this is some point D, right? So, what is the theorem? Theorem says if AB is a chord, and OD is perpendicular to AB, then what we have is AD equals to DB. And is again, I'm going to write theorem 4, which will be again same. If, any chord, if that bisector, that bisect point, for any given chord, if we take a point which is exactly at the mid, now from that point, if you will draw a perpendicular meeting to the center, right, it will be perpendicular. I mean, let me show you the theorem, okay? But this diagram will be valid for first and second. This is valid for third and fourth. Okay? Now what does theorem 4 says? T4. T4 is that the line joining the center of a circle to the midpoint of any chord is perpendicular to the chord, right? So I think quite clear. So 1, second is converse of 1, third, fourth is converse of third. Simple. The line joining the center of a circle to the midpoint. That means if from this point O, if there is any chord, let me take this chord, right? So from O, if you draw, not draw actually, you will be joining them. So if this is O, this is some point which is the bisect, which is at the midpoint. So if these two are equal, this is the midpoint. Now if you draw or you join them together, this point O, this point D, so OD is going to be perpendicular to this PQ. This is what fourth stage. Is there any doubt, anyone? Very much important. This is going to help you in your entire career. Whenever you will be, doing question from geometry where circle is there, right? These are the primarily theorems which you have to use. Right? There are more theorems which we'll be talking about, but for now, just these 4 and 5. Let me write the fifth one. Fifth one is, any doubt, anyone? Okay. Maybe everybody has not completed. Can I move ahead? Please respond to this. Theorem 5. I hope everybody has noted. There is one and only one circle passing through three non-collinear three non-collinear points. Okay. There is one and only one circle passing through three non-collinear points. Theorem 4, yes, Theorem 4 I'll explain, but you please write it Theorem 5 and then I explain Theorem 5 as well, don't worry, okay. Now I'll coming back to Theorem 4, right. Theorem 4 is Theorem 4. Let me draw a circle for this. This is the center, right? The line joining the center of a circle, this point, to the midpoint of any chord. Let me consider any chord, which is this chord AB. So what is the midpoint of it? Midpoint is this point, right? Midpoint is this point. Let me take this as D. So we are saying that if we join O to D is perpendicular to the chord. So it is going to be perpendicular, right? So basically if AD equals to DB, right, then you will get this OD perpendicular to AB. Is there any doubt? Coming along, please. If AD equals to DB, then you will get OD perpendicular to AB. Third was different, it's converse, simple. Still doubt? Coming along? Very good. In caps lock. Great. Yeah, so now you see. This point is or Theorem 4. Theorem 5 is not actually a theorem. It is just, I would say, kind of a universal fact, right? It is a universal fact. It's universal truth that a circle, a unique circle can only pass through three collinear points, right? Whenever you want to draw a unique circle, at least you need 3 points. I'm not saying that 3 point only, but yeah, at least you need 3 points. Let's try to understand this, okay? What if I consider 2 points and we will try to make those circles? If this is a unique circle or there are so many circles passing through any 2 points. So guys, if these are suppose 2 points, these are 2 points. Now, yeah, you please make these 2 points. Now my question is, please please plot some circle passing through these 2 points and tell me, is that a unique circle or more than one circle you are getting? Okay, I'll start doing this. You're also doing the same, I guess. One circle, right? Second circle. Is the second circle, third circle, right? Fourth circle, fifth circle. I think infinite number of circle, right? Through any 2 point, there is infinite number of circle. Say yes or no. Then only I'll move ahead. From any 2 point, this is point 1, this is number point 2. So from these 2 points, you can see there are infinite number of circle, right? What if I'll give you 3 point now? Suppose these 3 point. 1 point, 2 point randomly, this is the third point. Now can you tell me how many circles you can draw passing through these 3 points? Okay? We'll start plotting again. So this is, I think this will be the case, okay? Probably this one. Last point is not circle, huh? Rest it is a circle. Clearly it's a circle, it's a unique circle, right? Okay, so this circle can pass through this point and this point and this point. So how many minimum number of points you require to draw a unique circle? So answer will be 3. Is that clear? Now you see. There is one and only one circle passing through 3 non-collinear points. We understood so far that yeah, we need at least 3 points, or I would say from any 3 point we can draw a unique circle. So what about this unique thing, right? This non-collinear, right? I think yes, non-collinear means, why we are saying non-collinear, because these 3 points are non-collinear, right? If you take 3 collinear point, collinear means they are lying on the same line. So this is 1 point, 2 point, 3 point. Again, this is a system of 3 point, but they are collinear. Now there is no circle possible at all, right, which can pass through all the 3 points. Is that clear? So you can make a note actually. No circle can be drawn passing through 3 non-collinear points. No circle can be drawn passing through 3 collinear points. Three collinear points. Please, if you have any doubt, ask me. See, first of all, to draw a unique circle, you at least require 3 points. What kind of point? 3 non-collinear points. That means they should not lie on a unique line or on the same line segment. Is that clear, everyone? I need reply from each and every center. There are a total of 5 centers. Five centers alive. Can you show me? Now we will do questions, okay? If we are good so far, now we'll do question. Itanagar, Shillong is there, Senapati, Ukhrul, Tamaglong. Okay, thank you. Very good. So let's do some question now. We'll start from easier question. Question is, first question, the radius of a circle, is 13 centimeter. It's 13 centimeter, and the length of one of its chord is 10 centimeter. Find the distance of the chord from the center. So much easy, right? Maybe language will be tough to understand, but it is easy, right? Its chord is given 10 centimeter. Find the distance of the chord from the center. So this is nothing but the perpendicular distance of the chord from the center, or length of the perpendicular that will be drawn from the midpoint to the center, right? So I think this is quite clear. What is the answer, guys? How we will be finding the answer? Let me draw a circle for this. It's a bad circle. Okay. Can we get a smaller one? छोटा वही सर्कल. क्या पूरा चैप्टर सर्कल है तो थोड़ा छोटा. No, that is not the correct answer. Some mistake is there, I think. 3 is not the answer. Itanagar, no. Try it one more time. See, this is the diagram, right? This is the diagram. बंद है क्या? ये थोड़ा बड़ा है, छोटा सर्कल चाहिए था, ऐसे कुछ होगा उसका. कैप ऐप वगैरह कोई ऑन कर देना माइक. Guys, can you hear me? Anyone, please respond. This is the center of the circle. Let me take this O, and we have any chord. Yes, 12 is the correct answer. Very good. Tamang Long. So let me take this as AB chord. Now you see, find the distance of the chord from the center, right? So we have to find this. Let me take this as point D. So OD we have to find, okay? Also, what we know already, that if this is perpendicular, since OD is perpendicular to AB, that means, what that means? That is AD equals to BD, right? AD equals to BD. So if using the concept of AD equals to BD, right? So this is total of 10, so this will be 5 and 5. Okay, this is 5 and 5. What we have is AO is given as 13. AO is given to us 13. centimeter. OD you have to find. AD equals to 5 centimeters. So using Pythagorean theorem, in triangle, right angle triangle ADO, we have OD square equals to AO square minus of AD square. Please check it. This is a right angle triangle, right? So this length, OD square length, would be AO square minus of AD square, right? So here we get 13 square minus of 5 whole square. This is 169 minus 25, which is 144. This is a quite known result to us. OD will be 12 centimeter. Okay, so OD is 12 centimeter. I think that is the answer for this question. 12 centimeter. Is there any doubt, anyone? Next question is, find the length of a chord, which is at distance of 5 centimeter from the center of a circle of radius 13 centimeter. Sorry. You have to find the length of that chord. Tell me what is the answer. Question is clear to all of you? Let's start finding this. This is the center O, and there is one chord whose length we have to find out, and from the center, let me take this as again AB. So OD is given to us, right? 5 centimeter, and we are known that radius is 13, so this is 13. What we have to find? AB we have to find. Okay. So yes, that is the correct answer. Very good, Itanagar. Now as we know, this is perpendicular. If this is perpendicular, so again using the same theorem, AD is equals to DB. So let's find out AD first. What is AD? AD square is AO square minus of OD square. So this will be 13 to the whole square minus 5 square, which is 169 minus of 25. So it is 144. Data is quite same, right? But it is what? AD. If AD is 12 centimeter, this much is 12, then what is the total? That will also be 12. So total, or I would say the length of chord AB equals to 24 centimeter. And that is the final answer. 24 centimeter is the correct answer. Very good. Those who have got the answer. Is there any doubt, anyone? Okay. Next question will be a good one. Try to solve this. Question is, two circles of radii 10 centimeter and 8 centimeter intersect and the length, two circles of radii 10 centimeter and 8 centimeter intersect and the length of the common chord is 12 centimeter. Find the distance between their center. This question is all about, plotting the correct diagram. Once you will plot the correct diagram, you will get the answer very easily. Right? So let's give it a try. Okay, I can give you some hint like how to draw this diagram, what is common chord exactly, and how these are two circles they will be intersecting. Okay, so this is suppose the one circle, and this is, let me take the other circle. This is nothing but the common chord. Let me take this is PQ. Common chord means this is chord for this circle, and this is also the chord for the bigger circle, the first circle. Right? Now radius are given to us. This is given to us 10. Let me take this is O. This is some center as O dash. So OP is given 10 centimeter, right? And O dash P is given to us 8 centimeter. Length of PQ is given to us 12 centimeter. What do you have to find? You have to find the distance between their centers. So we have to find this distance. Which one? This one. O dash. O dash you have to find. Alright? Question is very easy. We are just, kind of plugging two circles together. So what we were doing initially for one circle, so again we have to do for the second circle as well. And then, the total distance will be their summation. I'll show you how. What is, guys, OO dash? OO dash is, let me take some point here, let's say point M. Okay. So what is O dash? O dash is the summation of OM plus of MO dash, right? OM, this distance, plus this distance again. Now, how would you find OM? From triangle OMP, right angle OMP, and this will be finding from triangle O dash MP. I think this was the enough hint to solve this further, right? Because if this is a right angle triangle, so again using the same concept, right? Can you tell me what is PM also? PM will be 6 centimeter, as total is 12, so half will be 6. Now let's apply the formula one by one and find out OP, OM and MO dash. In right angle triangle OMP, OM will be square root of 13 square minus of 6 square, right? Here in this case OP square minus of PM square. So PM is 6 and OP is 10, it's not 13, it is 10. So 10 square minus 6 square, what is this data coming out as? 100 minus 36 equals to root 64 further. OM is equals to 8 centimeter. OM is equals to 8 centimeter. Is that clear? So OM will be 8 centimeter. Now you see. In triangle, in right angle triangle O dash MP, O dash M equals to 8 square minus 6 square. Why? Because again, just look into this triangle, okay, this triangle. Is it clear? So this is the hypotenuse, this is the your base, this is perpendicular, any of this, right? So O dash M square plus PM square equals to OP dash square, O dash P square. So this is the data we have. O dash P is given 8. So let me see what we are getting. 8 square is 64 minus 36, which comes out to be root over 28, which is 5, right? 5.29. Now you should know how to find square root well, right? But if you do not know, please you just have your answer as the greatest integer point, I would say, the nearest possible value. Like 5 we know. Then again we have 25 plus something 3. So accordingly you have to work on, like 5.29 you will get. Or 5.2 is also fine. 5.3 if you want to write, that is also fine. Okay? And that is the reason I always recommend my student to remember some squares. And you guys know how to find the square root of square of 52, right? Direct method. We know the direct method of how to find the square. Like 52 is there, so 25 plus 2. Okay, I'll not go into this, but yes, we have covered this in my initial lecture. Initial 2 or 5 lectures we have done this, right? Vedic maths, short tricks, all of this. Yeah, so this is 5.2 or 5.3. Now, next is OO dash. Hence, I'll give you time, don't worry. OM plus of MO dash, which is 5 plus, this is 8 plus 5.29. So answer is 13.29 centimeters is your answer. Okay, now please copy it. 13.29 will be the answer. This is such a nice question. If anyone having any doubt, please let me know. I'll discuss it again. You are supposed to draw the diagram first, right? And then say things are very easy. Mass is just, what we were doing in the previous two example that we are supposed to do. So length of perpendicular we will find out from this circle, length of perpendicular from the another circle, and then we will add them together. So that will give you the total length between the centers. Clear? Okay. So is there any center who want to copy, or we are done? Tell me. If we are done, I'll give you next question then. Next question is, if a diameter of a circle, bisects each other, if a diameter of a circle bisects each of the two chords, there are two chords in this system, right? Each of the two chords of a circle, prove that the chords are parallel, right? The chords are parallel, this you have to prove. If a diameter of a circle bisects each of the two chords of the circle, prove that the chords are parallel. It's a very simple diagram. See, if this is a circle, if this is any circle, let me take this is the diameter. If this is the diameter of the circle, okay? Now see, if a diameter of a circle bisects each of the two chords, so how it will bisect the chord? Of course, when they are something like this, right? This is what the whole diagram is. Clear? This is somewhere center of the circle. This is the center O, and two chords we have AB, CD or PQRS, whatever. So let me take PQRS, right? Okay, so what is the question, guys? Question is, the diameter of a circle bisects each of the two chords. So this is, so far we are given that PQ, let me take some point L, this is M, right? So what we are having so far, that PL equals to LQ, and we have RM, this is point M, so M, Rm equals to Ms. Clear? This is we are given with. What we have to prove? Prove that chords are parallel. What we have to prove? To prove that PQ is parallel to RS. Now you guys know. You better know how to prove any two lines are parallel. So the same concept you have to apply here. Right? Try to solve. There is no new concept you have to use, just the old concept. But the thing is that I have not given you any data, numbers, right? Which is quite scary, I know. But this is last chapter. We have covered all kind of proofs, right? How to prove if two triangles are, two quadrilaterals are parallelogram, when two line segments are parallel. All of that we know. Try to solve. PQ is parallel to RS. Always remember this is given to us. And some other facts we also know already. That if this is the line joining of the center with the midpoint, so it will be perpendicular. So that is the reason I have taken this perpendicular, and as well this is also perpendicular. Okay, so this you have to use. I think I have told you the answer also. But let's see. You remember something like alternate angle? No? Alternate angle means two parallel lines. Right? If this is the situation, right? If this is the situation, if these two are parallel and this is the line segment, you see? So if this angle and this angle are equal, they are parallel. Right? In this case, what we are given? This way. If these two are the, this is the one chord, this is the another chord, this is the diameter. This is the situation, right? So, yes. If this you can show 90 and this is also 90. Alternate angle will be equal only when the line segments are parallel. So, this is what we were supposed to prove. See, what you have to write in the boards or your school copy? Something like this. Since the line joining the center, since the line joining the center, since the line joining the center to the circle, the line joining the center of the circle to the midpoint of the chord, midpoint of chord is always perpendicular, right? So using this fact, now I can tell you what is the proof. Perpendicular to the chord. So guys, if in these two line segment, what we have is angle PLO equals to 90. Even that is also equals to QLO, by the way, right? From the another chord we will get OMR. OMR equals to 90, which is also equals to SMO. This angle, right? So now from 1 and 2 you can write here these two angles. Which angle? This angle and this angle. PLO equals to SMO, hence PQ and RS are parallel. Right? Why? Because they are alternate interior angle. Proof. This is the proof. Is there any doubt, anyone? See, sometimes, in the question of geometry, whenever you are supposed to prove something, you will get an institution, okay, okay, this is how we can prove this, like this is the theorem. If we write this will be the construction part, and this is how we can prove. But that is not enough. You have to show it on the copy, on your paper, right? Whatever formula you are using, whatever theorem you are using, whatever axiom you are saying that using this particular, using axiom or postulate, we are making this comment or conclusion. So that all you have to write. Then only you will be able to get complete marks. This is the drawback of question which are, the proof question. Not in case of numerical one, because in numerical one, they are mainly focused on the answer. If 13 data was there, 5 was there, so it was supposed to be 12. Are you getting 12? Yes. Then full marks. I mean, they may check, but yes, in proofs, words are very important. So this is, you have to write. Okay? Something like this. If better you know, you can use that. Any doubt, anyone? Okay, let's move ahead. Let's do a better question. Question is a good one. Question is AB and CD are two done. Very good. Question is AB and CD are two parallel chords of a circle which are on opposite side of the center. We have some prior conditions such that AB equals to 10 centimeter, CD equals to 24 centimeter, right? And the distance between AB and CD is 17 centimeter. Find the radius of the circle. First of all, it is very much important, so make it for revision. Whenever you will revise a chapter, you will definitely look into this problem. AB and CD are two parallel chords of a circle which are on opposite side. So let's draw the diagram. Okay. If this is the diagram, this is the center we are given. We have two chords. One chord, this is some second chord. Let me take AB. and if you were to meet them, they are 90, 90. And please, they are parallel actually, right? So AB and CD, something like this, they will be parallel, right? Now this is the center O. Let's come to the question now. Such that AB equals to 10. AB we have 10, right? So total we have 10, so this is going to be 5 then. 5, 5. CD is 24, so this is going to be 12 and this is also 12. And the distance between AB and CD, so if I take this as M and this as L, so what is given to us? ML equals to 17. ML is given to us 17. Now, we have to find the radius. So, let me consider this as R, right? And for this chord as well, this is also R. This is the radius we have to find. Alright. Now what else we need? What else we need is, we need this distance, MO or OL. Right? Then only you will be apply the Pythagorean theorem in this triangle and this triangle. We are not given that MO or OL is some values, right? We are given with the total distance between this point M and the L. So what we can do is let MO equals to S. If MO is X, guys, if MO is X, what is this? 17 minus X, simple. Now let's start with this. In right angle triangle CMO. Okay, we will get a relation between R and X. Similarly here as well. In triangle ALO, you will again get a relation between R and X, and on solving you will get the value of R and X both. Let's find out that. In triangle CMO is this one. So what we can write is that R square equals to X square, okay, OC square equals to OM square plus CM square. Now what is OC square? It is R square. What is OM square? That is X square plus CM is 12 whole square. So this will be R square equals to X square plus 144. This is equation number 1. Clear? Similarly, if you were to solve in this, you will get AO square equals to OL square, AL square. This is what AO square is, again R square. OL square. What is OL square? OL is 17 minus X. So this will be 17 minus X to the whole square plus. What is AL square? So AL square is 5 whole square. So let me rewrite it again. It will be 17 minus X to the whole square plus of 25. Is this clear, guys? Because rest is just to solve this, right? These two. This is 1. Okay, this is 2nd. So you see what we can write to, sorry, this is not 2 actually. Let me solve this further. It will be R square equals to 17 square is 389. No, sorry, it's 289. 289 plus X square minus of 34 times X plus 25, right? So this is nothing but 2. Now if you were to solve 1 and 2, from 1 and 2, what we get? We get R square equals to R square, right? So we can equate their right side. X square plus 144 equals to, in this side we get 289 plus X square minus 34X plus 25. Is that clear? So now x square gets cancelled. This is how much? 34x. 34x on this side, we get 289 plus 25 minus of 144. So this will be 4, this is 1, this is 3, minus of 144. On solving this, we get 0 and we get 17. So this is 34x equals to 170. On solving value of x, we will get how much? 17, it's not 170. 289 plus 25, 3, right? And this is what? X square minus of 144. No, I think this is correct. 170, right? 170 we are getting. So 170 is the correct thing, correct value. Where it is minus 354? There is nothing minus 354, guys. This is minus 34. Right? We have applied formula of a plus b, a minus b whole square. Please check it. So this you will get 5 actually. Right? Yeah, that was correct. So x value is 5. X equals to 5. Now, putting in equation number 1, we get r square equals to x square plus of 144. That is 25, right? X equals to 5 plus 25 plus 144, which is 169, and r equals to 13 centimeter. And r equals to 13 centimeter. Yes, dear, minus 34 will be there, na? What is a minus b ka whole square? A square plus b square minus 2ab. So minus of 70 into 2 into x. That will be minus of 34x. It's easy, right? It's easy. Please try to solve this, and when you are done, let me know. If any doubt anywhere, please ask me. Do not just say yes. Is this clear, everyone? By the next class, we will finish this chapter, okay? Great. Or maybe we will take one more lecture, that depends. Okay, please take your time. I'm not in a hurry, take your time. Do I need to scroll up or down? Or on the same page? I'm actually making it page 1. This is like something like page 2. So you can refer me page 1, 2 or 3, right? So accordingly I'll show you page 1, 2 or 3. Clear? Which one? 1, 2, 3, which one? Silong, can you please raise your hand? Shillong Center. Okay, okay. I think I cannot see you. Is there any camera in your classroom? Well, we are about to end this class, so not a point. Which page are you done? Any center, any doubt? Please. Next question is, in the figure, O is the center, of circle, whose radius is 5 centimeter, right? Next, OP is perpendicular to AB, right? And we also given that OQ is perpendicular to CD. Also that AB and CD are parallel. Further, AB equals to 6 centimeter, and CD equals to 8 centimeter. Determine PQ. You have to determine what is PQ distance. Clear? Now I'll show you the diagram, because in the figure I have not shown you the diagram. Diagram is this. This is your diagram. This is the circle O. This is one chord, this is the another chord. Is there any network problem? This is given as AB, this is as CD, this is P, this is point Q. Okay, this is the diagram. So this time both the chords are at the same side of the origin, of the center. So you have to find PQ, which is nothing but the differences of the distance of OP and OQ. So I think question is easy, but just you have to understand that part, that how to find exactly PQ. Because data is so much na, some of the guys will even give up. Okay, this much of data. I have seen such cases. So that is the reason. Always at least go through a question once. And if there is no figure, try to make a figure. And in this case, already figure is there. So I think this is quite easy. Otherwise, you should always try to make a crude geometry or, that particular curve. If you still find no, I will not be able to solve, or some parameter is not given, how should I construct something? No clue, right? No clue. Then you can skip. At least try the figure part. That is very much important. Even in board, sometimes you will get marks for your figure and, what we call it, partial marking. Right? If 4 marks or 2 marks, suppose you'll draw up correct figure, and you will show this is AB, this is O, the center, perpendicular, all of that. You will get half mark, 25% mark you will get. So do not just, put your paper blank at all, right? Write something on it. Yes, you are supposed to find the length of PQ. That is correct. PQ. Determine PQ. refer to this data. I think this is the last problem for the day. Sorry. So what we can do is we can meet these two. Let me join AO and similarly OC. Right. So in right angle triangle APO, in right angle triangle APO, what is OP square? OP square will be AO square minus of AP square, sorry. OP square, this square will be hypotenuse minus base. So that is what? AO. Where is AO now? Radius is nothing but the AO. I think AO equals to CO equals to 5. Right? This will be 5 centimeter. So using 5 centimeter, 5 square minus, what is AP? AP. Where is AP given? Yes. AB is 6, so AP will be 3. CD is 8, so CQ will be 4. No? Itanagar, any doubt how we are saying that radius is 5? AO equals to CO equals to 5. Why? Because they are all radius. Right? So that is the reason. If AO, OC or any other length which is radius will be same, 5. Okay? So now you see. In triangle, in right angle triangle A, this point, please refer to this. 1, 2, this. So we are talking about this triangle, right? So what we conclude is that 5 square minus, this is what AP, which is 3 square. So you will get 25 minus 9, which is 16. So OP square is 16. We will get OP as 4 centimeter. So OP we are getting 4 centimeter. Now, next is, again, in right angle triangle, CQO. OC square will be, here you see, COQ or CQO, right? This is 90 degree, guys. So OC square, you can write as summation of CQ square plus OQ square. OQ square. Now what is OQ distance? So again, OQ distance you can write as OC square minus of, well, anyway, I have added one more step, by the way. It's okay. OC square is 5 square again, minus of, what is CQ? CQ is 4 centimeter. Right? If this is complete 6, so this will be 3 and 3. If this is total of 8, they will be 4 and 4. So this time it is 4 square. Again, 25 minus 16 equals to 9. So what we are getting? OQ square equals to 9. That is OQ equals to 3 centimeter. OP we have got what? 4 centimeter. OQ we have got 3 centimeter. Hence, PQ equals to 4 minus 3, or let me write OP minus OQ, which is 4 minus 3, which is 1 centimeter. So 1 centimeter is the correct answer. So get ready for this kind of question where you will get 2 chords or maybe 2 circle intersecting, and they are giving you a common chord. If 2 parallel chords, then there will be 2 kind of question, maybe on the same side of the center or maybe they are on the opposite of the center. So you will be able to solve. I hope that. Is there any doubt, anyone? Itanagar, Shillong, Senapati, Tamenglong, Ukhrul, anyone? Please ask your doubt. This was the last question for the day, and in the next class we will continue with some more theorems and more illustrations. Clear. Very good, Silong. Very good. And please, you start solving your question in your NCRT textbook if you have, or you can also solve the question from your textbook, right? Your state board textbook. Otherwise, I'll share the question from NCRT so that you can refer to. It's okay what question you are solving. They ultimately going to help you, right? Whether they are from any other material or NCRT or state board. Yes, yes, please. All right. So, yeah. Any doubt, anyone? Shillong has no doubt. Tamenglong, they have no doubt. Itanagar, Ukhrul, Senapati, please. Very good, very good. So I think everybody is clear with this, right? Very good, very good. So we have done almost 7 to 8 problems, and we have also covered a very important segment of this called circle chapter. And believe me, this is going to help you in class 11th, whether it is class 10th or JEE preparation or in general science also, right? This theorem is very important. If you draw a perpendicular and to join the center, it will be bisecting. So yes, this was for the day, and with this, please take care everyone. Bye-bye. Good night, and we'll see you in the next class with more questions, with more theorems. Yes, thank you. Thank you, Itanagar. Thank you, everyone. And also, you too, Itanagar. So good night, everyone. Take care. Sweet dreams. Sweet dreams, yes. If in the dreams you're not getting any math question, then of course it will be sweet. Because I have seen kids, they are very afraid of mathematics, especially mathematics, right? So yes, bye-bye everyone. We'll see you in the next class. Take care.